This is Code.org's App Lab, and this is my incredible, amazing, super awesome snake game based on the classic game, well, the classic snake game. Let me show you what it is, and then we'll talk about how you can build one and how you can build an incredible game, even better than mine, and share it with the world. Let's hit play. Let's see. Whoop, that way, dude. Toot, 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 ah. And you can increase or decrease the speed. I'm not that great at this, so I kind of left mine where it is. I was testing it out and I kept losing. I had to make it a bit easier. Wada! And as you can see, Snake slowly grows. The food's a bit randomized. The food is actually alt code images or alt code emojis, you could say. I'll show you. I'm about to lose here. Quaba! Oh no! And here, let's dive into that first, actually. So if I go to design, I can show you what I mean. Well, it's all going to be hidden in here. Well, first off, let's talk about these. Each one of these is a label box. It's empty label box. And that's what I'm using kind of as the pixel to be colored, to have the colors change and go up and around throughout it. So that's how the snake's movement is created. The eyes and then the other items are, and these are buttons obviously. Oh, here's the I do 25 by 25 for mine, and then I have it 12 across, and I actually went 13 down. So, and the game is linked in the description, right, with all the code right below this, the description. Play it, have fun, get ideas, look at the code. So, now, the food items I was going to show you real quick. We'll get to them as well later. But here they are, and these are all emojis. You can Google like Unicode emojis today, and that's some of them, and the eyes are the same. So let's kind of dive into the nuts and bolts of this. Here are global variables. Global variables mean that every function in this program can see and use them. So we have a snake cell array or a snake's cell list, and what that is it's the X and Y coordinates of each point the snake is at on the map or on the grid. And I'll show you what I mean. The food location, so we keep track of that, just an X and Y coordinate. Letters, so, well, letters, because I used, right, this is, oh, that's the score. This is the C5 block, D, E5, so A4, C4, C5. All right, so letters, the score starts at 0. The direction is right to start, so I start our snake moving right. Our color options, that are randomized, so each time you hit run, you will get a different color. Well, a few different colors. Variable random is set to random. Color options, length -1, that just gets the length of this list, subtracts 1 from it, because the length will say 6, and there's 6 items, but there's 0, 1, 2, 3, 4, or the length will say 5, and there's only 4 indexes, because we start at 0 for indexes. Color options are color equals random. Oh yeah, so then I use this random number to get our color, and then game over is false. All right, now on the event that the user clicks the start button, this runs. And what we first do is run clear board. And that is because this play button is the start button. That's because the user can click to restart mid-game. And so it just clears off the board. So what does clear board do? It is way down here. But clear board is going to, I see some extra space. Let me just get rid of them. There are. Clear board. So variable cell. So we're going to use that in a second. And then this is an if statement. If snake cells dot length is greater than 0. So if my snake's length is greater than 0, and I can show you what snake cells looks like. Watch snake cells. Oh, is it not going to let me? Cells. Oh. There we go. And so this is the snake cells, and this is the letter. It's the 10th letter in the index, and this is the number row, which is 2, right? And the 10th letter in the index. This is the tail of him, the last two being the head. So anyways, I say, hey, if snake cell's length is greater than 0, so if there's an image of a snake on the screen, right, if this is true, we run this code. What does this code do? Well, for I equals 0, okay, so I is going to be our counting number. I is less than snake cells dot length. So right now that would be less than 4, right, because of the length of 4. I equals I plus 2. So we're going to do a loop. We're going to use I to count. I has to be less than the length of snake cells. And each time we loop through, we're adding 2 to I. So I starts at 0. Cells equals letters. Snake cells I. I is 0. So snake cells 0 is 10. So the letter that the tail is at, right, because this is the first letter, is 10. Well, what is 10? If you go up here and count, and remember, arrays start at 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. K. And that would be correct. K is the second to the last letter. So, K plus snake cells I plus 1. Okay, so snake cells I, well, what was I? We started at 0. Plus 1 is 1. So the second index of our array is 2. So this would be a 2. Snake cells I plus 1. I was 0. I plus 1 is 1. The index of 1 is 2. So this would equal 2. So we add together the letter K and 2 and get K2, which is this cell. We then set that cell to white. And then we also set the property of the text. Oh, that's after the loop. And that's because only the eyes are at the end of the animal. Yep. And then we go back and we loop around and around, going through each 2 points, right? Jumping through each and setting it blank to white. And then finally we set the eyes also to nothing. And then we grab if food location, so that would just be an XY coordinate too, right? So I'm going to Control C to copy, Control V to paste. So here's the food's location. So if food dot length exists, so yes, that's large. Cell food letters, blah, 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 blah. Same deal. I grab this, use for to get the letter. The letter is A, B, C, D, E. So E would be 4 because 0, 1, 2, 3, 4. So 4 and then row 1. And I set the text to nothing because it's an emoji and I clear it out. And then I clear out the snake cells array. I don't worry about clearing out the food array because it gets overridden anyways. So that's what we start off with. Timed loop. Stop the time loop. That's in case the game was already running. We don't want it to continue to run. Set property title hidden true. Okay. Title, we're going to hide the title. Game over hidden true. We're going to hide game over. Snake cell equals snake cells dot length equals random. So this randomizes the starting point in between 2 and 10. And this randomizes the snake cells. Oh, this is the letters. 2 to 10. So we might want to increase that now that there's 13. So maybe 2 to 12. Okay, show movement. To show movement number. Okay. Let's just test that out. Oh, I already lost. And we can try it again and again. Cool. So that's working. Great. All right. Anyways, so now we are randomizing the location, right? Snake cell, this is their number location. That's the letter location comes first, and then the number. And then we are showing movement, so we're starting the snake moving. Letter location, and then the number. Now, the random foods is going to be, show movement's a function, and then we randomize food. So let's go to show movement. Show movement is going to automatically set, this is what gets our snake to actually appear in the first place. We're going to dive into that in a second. So I'm going to go to show food first, or random food. So random food equals, the food array is set to be equal to all of this, right? And so that's an array of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 food items. And then we get a random number, which is equal to 0 food length minus 1, because the length will be equal to what? Did I just say 10 items? But the indexes are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we don't want to use 10. We want our random number to be 0 to 9, which is food length minus 1. Food location, 0, so this is the global variable I declared at the top, is equal to the random number 0 letters length minus 1. So a random letter index is what I want for the food. Food location 1 is equal to a random number 1 to 13, because that's how many rows there are. And then I set it up just like I explained with the snake cells array. So the first element is and every odd number element, I guess. No, every even. Because 0 element is going to be the index of the letter, right? So maybe if it's 1, that would be a B, right? So it's the number, it's the index of a letter it represents at the 0 point. And then the 1 is going to be the row number. So, and then I set property letter plus, so I smash these two together to create a string, and then I use set property, right, on the food's location, 0, which is equal to some letter, because we put letters here, so food location 0, whatever letter is at that point, and then food location 1, which is whatever random number we got here, random number here, random number here, text food random. And so food random is going to grab, using this random number, the which food emoji we want, and it's going to randomize the location using this random and that random. So, all right. Lots of random. And then random snake speed. Let's go to that. Snake speed. I set this equal to 500. That means 500 milliseconds each time. This loop, this function runs 500 times per millisecond. Per second. Twice per second. 500 milliseconds is half a second, and this is run in milliseconds. So if I set it to 10, that would be 100 times a second, right? So 500 is twice per second, and what does it do? If direction is equal to right, if it's equal to left, if it's equal to up, and when you click on the left button, the right button, right, the right button, the down button, the up button, you change the direction equal to whatever. So say I just clicked up, direction would be equal to up. And so then I would go into this if statement, and again, 500 times a second, it's checking. Okay, what's the direction? Okay, what was the last direction clicked? It doesn't have down because it defaults to down. And then whatever it was, if right, horizontal move 1. And then remember, if an if statement's correct, if this is true, it is set to right, it wouldn't even look at this other stuff because this was already true, so this isn't possibly true. All right. Else, so say this is false, it doesn't run the code in here, it's then going to check the direction to left. Then it's going to direct the direction to up. And if it was up, we would then drop in, run vertical move -1. And remember, we wouldn't have run this stuff. And then we would go to that. So let's take a look at, well, we're actually going to get to both of those just about now. So that brings us to the keys, right? So when you hit up, down, left, right, what happens? Well, horizontal move, and then direction equals right. Vertical move, direction equals up. The direction is this speed. Snake speed is the automatic movement that runs every half second. And then hitting the keys makes the snake move separately. And that's how you change the direction. But the snake is still automatically moving forward every half second in the direction you last hit. All right, so let's see. Let's say I click one of these. Let's go explore horizontal move. So horizontal move 1. horizontal move. Letter change, okay? And I'm saying that because letters is what would be changing. As you move horizontally in this, your letters either go up and down the alphabet. And so I'm changing the letter by 1 because I'm changing letter indexes by 1. If I was at C and I wanted to go right more, I need to go over to D. So I'm adding 1, and that would mean 0, 1, 2 if I was at C, and I need to add 1 to get to 3, which is D. So letter index, then my letter index change would be 1, right? I want to add 1. If game over is set if you hit a wall. So we'll do that later, but not game over. Variable old letter equals snake cell's length minus 2. And that will be, let's just get an end game here. That will be the, oh, but it's right there. Here. Okay. So, snake cell's length minus 2. Snake cell's length is 8. Okay. And then minus 2 of the length is 6. 0, 1, 2, 3, 4, 5, 6. Which is good because every even number is a letter index. So that's 9. So what am I doing here? I'm getting old letter index. So the head right now is at 9, which for us would be J. And then the letter change that I want to do, I hit right, theoretically. And so I would want to add 1 to that. So old letter index, which was 9, plus 1 is 10. I then say, get the number. The number's right next to it. All the odd indexes are the numbers. So 1 would be the number, right? Letter J, 1. And so I take 1 and I smash it into my array with J, right? And, no, I take 1. Okay, so now I have the number 1. Now I'm going to check new number letter index, new letter index. Is it less than 0? So if I hit left, am I off the screen? Am I going off the screen? Because if so, then I run game over. Else, so if this is not true, then I automatically will do this. If I do this, I never do this, right? So if this is not true, the game's not over. Set property letter, old letter, plus 1. Or I know it's 1 here. Whatever number row you were at, whatever letter you got up here, we smash those together and set the property text to blank. Okay? We then show movement. So we set the properties to nothing, and then we run show movement, the new letter index, which means the plus 1, and the number. Okay, new letter index and the number. Let's go to show movement again. Letter index plus number. So now we have our letter index. Letters equal letter index plus number is the new head. Our letter index, our new letter index, okay? And notice that we got rid of the I's for the old letter index. We do show movement on the new letter index, and I've already gone through show movement, but I just want to point out, I use that new index to get the letter, I smash it together with the number, and then I am going to go back through this. Oh, did we not do show movement? I'm not sure. If get property head background equals color. Right. So we did it for the, okay. So if the heads, okay. So this I check if they're running into themselves. If there's color that they're moving into, then we should not move their game over, because that means they're hitting themselves. Set property new head background color, and that's the color randomly picked. We then of course have to move the eyes along with us. Then I'm checking if not ate food. So if during this round I did not eat the food, tail letters equal letters cell z. So the tail are these last two. And what I'm doing here is I'm going to get rid of them. Right, yeah, no, I'm going to get rid of these two tail numbers. They don't need to be colored anymore because I'm adding, because of the forward movement, I'm just, it's not physically moving forward. I'm going to stop color in this one, and color if there was a block here, and it looks like it's moving forward. Then I'm going to blank out this box and put color here. Then I blank out this box and put color here, and it looks like the whole thing's moving forward. And then when I eat food, I just add one extra color box following me behind. And so that's what's occurring here. Set property background white, so I blank out the old tail location, I remove those bottom two cells, and I add the new numbers to the front of the array. Snakes, letter, index. Oh, yep, and then I add these two numbers to the beginning, to the end of the array at the length. So the very end goes the letter first because it's at the even spots, and then the number. Okay. Now, 8 food, all I'm doing there is 8 equals false, same letter, so snake cell. I check to see if the food, and I've gone through how to get the letters and the numbers, I check to see if the letter number combination is equal to the food location. So these are Boolean values, and if the food location 0, which is the food's letter, is equal to the snakes, this would equal true. I then check if the numbers are also the same, the food's location, snake's location, or the row numbers. And if that's true, then when I come down here, this is either equal true and this is equal true or false. If these are both true, then 8 equals true. We randomize the food, which we went through. We add 1 to the score. We update the score, and we return 8. Randomizing the food wipes out the food here and puts it somewhere. Oh, we don't need to wipe out the food there because the snake does with his eyes moving into the square that it is in. Let's see. I think that about covers it. Let's just check out game over. Sounds so sad. Snake speed. Clear board, yeah. Game over looks so small. So what we really need to focus on is stopping the timed loop. That stops the automated movement, and game over is run when we hit something like ourselves or the wall, right? And we set the property game over to show, and then game over equals true, and that just doesn't let the user play with the keys. All right. That just about covers it. I want to point out again, this is in the link to this all is in the description. You should definitely check it out. Make your own awesome game. Post it in the comments. Remix it. Have fun with it. Get good ideas. This does include, I think, all the requirements for a AP computer science performance task project, or very close to it. No, it should actually cover it. So this is definitely something you could explore for something like that. I'm going to get back and attempt to win the world by eating all this random food. Bum-ba-da-dum. I'm never that good at the games I make. Ooh, pizza. I like pizza. Ooh, cookie. Cookie or a biscuit. Like a really bad pancake. Or, ooh, more pizza. I love pizza though. Like, I have to... Okay, well, that was a good try. Go make something awesome. Post it below. Yeah.